All right, this is section 9.5 where we talk about two more rules dealing with derivatives. And the first one is the product rule. So if you got a function that's a product of two functions, u and v, the derivative of the function is the first function times the derivative of the second, plus the second function times the derivative of the first. So if we start out with this function here, and we got two separate functions here. Here's your u and your v. So you take the first function, unchanged, times the derivative of the second, which is just 2x, plus the second function, unchanged, times the derivative of the first function. And then it's just a matter of expanding this out and combining like terms. This one, the first function, untouched, times the derivative of the second, plus the second, untouched, times the derivative of the first. And then they ask you to find f prime of 1, so you just plug in 1 for x and simplify it down and you get negative 72. Now you could have expanded everything out here, but they don't ask you to do that. They just ask you to find f prime of 1. So you don't need to simplify the function at that point. The quotient rule, if you got a fraction made up of two different functions, you're assuming the denominator is not equal to 0 because you can't divide by 0 in mathematics. The derivative is simply the denominator times derivative of the numerator minus the numerator times derivative of the denominator over to the denominator squared. So v over u's derivative is v u prime minus u v prime over v squared. Alright, so this derivative is the denominator times derivative of the numerator minus the numerator times derivative of the denominator over the denominator squared. And then the rest of this is just cleaning it up. Here you've got the denominator times the derivative of the numerator minus the numerator times derivative of the denominator over the denominator squared. And then everything else is just cleaning it up. And they ask you to analyze the function at 3. So you plug 3 into the function and you get your answer. Here are the quotient rule for 1 over x cubed. So your denominator is x cubed, your numerator is 1. So denominator is unchanged times derivative of the numerator, which is just 0, minus the numerator 1, unchanged, times derivative of the denominator, which is 3x squared, over the denominator squared. And so you get this guy, which simplifies down to this. Now we could have written 1 over x cubed as x to the negative 3, took its derivative and simplified it, and notice we get the same answer. Two different ways to take the same derivative. They ask us to find the marginal revenue and then check when x equals 15. So we use the quotient rule here. Well, two things. The derivative of 10x is just 10. The derivative of this guy is your denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. When you clean that up, you get this guy here. Now when you plug in 15 and simplify it, you get 10.20, which is the estimated revenue from the sale of the 16th flash drive because you plugged in 15. Number 5, sensitivity to a drug. Keep in mind C here is a constant, M is your variable. So M squared times C over 2 minus M over 3 is really M squared times 1/2 C minus 1/3 M. Makes it a little easier to take the derivative at that point. So the derivative is the first guy times the derivative of the second, and derivative of the second, that's a constant, so its derivative is 0. And derivative of 1/3 M is just 1/3, plus the second function, untouched, times derivative of the first, which is just 2M. Now when you multiply M squared times 0, you get nothing. M squared times minus 1/3 is minus 1/3 M squared. 1/2 C times 2M is 1/2 times 2 is just 1, and C times M is CM. 1/3 times 2 is 2/3, and M times M is M squared. So here's your function, but you've got some M squared terms you can combine. Minus 1/3 and minus 2/3 gives you minus 1 of the M squareds, and you still have the CM as well. So let's look at some web-assigned similar questions here. Question 2, take the derivative here, so it's first derivative of the second, plus second derivative of the first, and you multiply it out. Or you could have expanded this out and then taken the derivative at that point. Notice you get the same answer either way. So on this one, first guy untouched, derivative of the second, plus the second untouched times derivative of the first, multiply it out and combine like terms. Number 9, I multiplied this out and combine like terms, and then I took the derivative. First guy is untouched times derivative of the second, plus the second guy untouched derivative of the first, and then I expanded it out and got my derivative that way. Now they ask us to analyze it at -2, so I plug in -2 and I get 40. Then they also ask us to find the instantaneous rate of change at -2, and you get the same answer of 40, because whether you're talking about the slope of the tangent or the instantaneous rate of change, it means the same thing. It's calculated the same way. Find the derivative for this guy. Well, it's bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared, and then simplifying. Bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared. Again, you simplify and combine like terms. Number 20, I multiplied the top and got this function on the top and that one on the bottom. Made it easier to do the derivative. So you got the bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared, and simplify it at that point. 21, bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared, simplifying. Then we plug in -2 and we get an answer. Then they ask us to find the instantaneous rate of change at 2, and we get the same answer because slope of the tangent line and instantaneous rate of change of the function are the same thing. 25, we take the derivative, so we got bottom, derivative of the top, minus top, derivative of the bottom over the bottom squared, and we simplify it down. And then they ask us to check at x equals 1, and so we get 10/3. They ask us to find the equation of the tangent line, so we have to find out what the original point is when x equals 1, so you plug 1 into the original function, and that gives you the point 1, 0 to use. You already have the slope of 10/3, so now you use the equation of a tangent line, equation of a line to find the equation of the tangent line. Knowing the slope in one point, you're able to do that. On this one, it says find the derivative, so we use the product rule, and we get this guy here. And now they say graph both of them on the same grid, which we did. And then they ask us to find the indicated points where, in part B, where the original function has a horizontal tangent lines. So here's your original function, this cubic, and it's got a horizontal tangent line there. It's got a horizontal tangent line there, which also happens to be where the first derivative equals 0 at -2 and at +4. And they want you to find the actual points where it's -2 and 4, so you got to plug in 4 and -2 into the original function to find those actual coordinates. And then part C says use the calculator to indicate all of that, and we've already done that on the previous page. 41 says find the marginal revenue when 49 units are sold, so you have to find the first derivative first. You use the quotient rule, and then you plug in 49, and that tells you that the revenue from the sale of the next unit, meaning the 50th after 49 are sold, the expected revenue is about $30. And 43, they ask us to find the marginal revenue, so we take the derivative using the product rule, and they ask us to find out what it is when the group contains 30 people, and remember x represents the number of people above 25, so that would mean x equals 5, and you plug that in, and that means as the group changes by one person to from 30 to 31, the revenue will drop by $50. 49, it shows the proportion of voters who recognize a candidate's name T months after the start of the campaign. And so they ask you to find the rate of change when t equals 6. So you have to take the first derivative and you use the product rule. And remember, the derivative of a constant is 0. So here's your first derivative, and you plug 6 into the function and you get 0.045, which means if this is month 6, then the next month, month 7 of the campaign, the proportion of voters who recognize the candidate will change by 0.045 or 4.5%. Then B says, what about 12 months? You plug in 12 and you get negative 0.010, which means the next month, the 13th month, the proportion of voters who recognize the candidate will drop by about 0.010, which is 1%. And so C, it asks you, question part C says, 1 month prior to the election, is it better for the P prime of T to be positive or negative? Well, it's better for P prime of T to be positive, that is, increasing recognition 1 month before the election.